in Humboldt who got the CAADRIA prize.
Ah. Mm-hmm.
It's this year's CAADRIA body.
Mm-hmm.
And yeah, it was good. I think it was also good attendance. I don't know the number, but it was very good.
Yeah, that's the difference between regular Zoom conferences and webinars. But it's if there's a large number of participants, you have to use a webinar. Otherwise, it's getting confusing. Yeah.
Right. We
are
in the panel, but we don't know how many people in the audience in the webinar. So we don't know.
Let me see. It looks as if quite a few authors were already there. Right. Yeah.
We haven't broadcast yet because we are in the rehearsal room.
Mm-hmm.
The audience can join when I start broadcasting. But just to inform Bob that this session, the continue of 2 sessions, which is yours, and you have 45 minutes.
Right.
Yeah, and it's about time already, and then it will continue with Mr. Kun Yun. Sorry if I'm pronounced wrong. The session 3.
Mm-hmm.
Finish your session. Would you mind to introduce him for his session too?
I would do so. Mm-hmm. So that's session 3.
Right. There's no break in between.
Ah, okay. Mm-hmm. I will do so at 8:45 sharp. I know that's in your case 13:45.
Yes.
Okay.
We'll text you for the reminder for if you have 10 and 5 minutes left.
In the chat.
In the
chat. Yeah.
And don't forget to inform the audience that they should leave the question on the Q&A box.
Right. We have been testing this already, so that the questions who have been answered, they are marked as such. Mm-hmm.
I'm not sure if you're ready. Does everybody in your session here, if you like to check the panelists or?
Yeah, let me see who is here. Nan Bai is here. Thomas Wortmann is also here. Right. It's not here. Eros Pereira is here.
And for all the panelists who is here, if it's not your turn, you can mute your mic and turn off the camera, please. Thank you. When you're ready, Bob, you can let me know, and then I will have the banner with the song to show that ready with for a minute.
Right, because the questioning does not follow the structure of the sessions. That is the sequence. I think we can rather simply start from scratch. Sure. I have prepared an image as well, which I would show later.
Okay.
I think we can start countdown right now.
Oh, sure. So
yes.
Let me show the countdown timer for a minute, 1 นาทีพอ, and then you can start right away. Okay, Bob?
Okay, that's perfectly fine. Mm-hmm.
มาค่ะ
Okay, a very good morning. I'm happy to chair this session on generative, algorithmic, and evolutionary design techniques. There is a large number of papers on one hand. On the other hand, we do have 45 minutes sharp, and that is, so to say, really a very good focus on discussion. I may assume that you have been watching the presentations, which is highly informative. I'm again happy to share this session. My name is Bob Martens. I've been in touch a long time with CAADRIA. I'm based at TU Wien in Austria. And in preparation for this session, I was curious what are the papers, so to say, containing, what are the topics, and I've been juggling a bit with the with this, and this is, so to say, a word cloud containing the most often appearing topical areas, and as far as I can see, you should be able to find yourself in this area. The size of the font also displays the so to say the frequency of the topics. That means that a smaller term, as depicted here, does not, so to say, is not does not have such a high frequency as other ones. Now, the question is how to start, and maybe let me see if there is already a question in the chat. Well, one question is, can we share our screen while presenting? Yes, you can, but of course there's not enough time that everybody is going to show 4 to 5 slides, because that would fully consume the time. So can I assume that everybody is well informed about the forthcoming presentations, correct?
Yes.
Okay, great. Maybe as a session chair, it's not uncommon to pose a very first question, and I would start with Likai Wang. I guess you are here, Likai. What is, so to say, to your opinion, the challenging side of design exploration?
Okay, can you hear me?
Yeah.
Thanks, Bob. I think the design exploration, the challenge of the design exploration is that the parametric model is like a paper in the 2017 says that the conventional parametric modeling tool like the grasshopper is actually will lock the designer or the architect into one type of the building design. So because if you use that kind of the grasshopper tool, you will find that although they can generate a large number of design variants, but actually they are look very similar. So it is very important to find a way to address this challenge and to make we just still using the conventional parametric modeling approach, but to make the model can generate the design have a very high variability and differentiation. My research is a kind of a very small step to explore the approach to doing so, but I think that in the future they can be more intelligent and more like maybe like the computer can reproduce the ability of the architects to generate the building massing design. So this is my opinion. Thanks.
Mm-hmm. Okay, there was one issue you were referring to here, and that is, so to say, how are you going to cope with a large number of alternatives or variants? And that's actually something which in the paper on spatial metaphors is addressed. Could you say something about this, Nakmi Shireen?
Yes, absolutely. Thanks, Bob. So, yeah, regards to what we have seen as there is a huge talk about having to have large number of design, creating large design variations, and we see that designers do that in their, conventional design exploration as well. But the system support isn't as much of a readily visible as possible, as expected. So one of the reasons that it is happening is because we don't know how designers, like perceptually, mentally, how can they handle huge number of variations at one given time. So we conducted an experiment, and we looked at their space use patterns, and based on that, we kind of like we kind of advise metaphors to interface designers as to what the things that they should consider when they're designing interfaces for such interactions, to look out for what could possibly that potentially those metaphors should help ease the process of making sense of a large design gallery of alternatives.
Yeah. So actually, what you're also saying is that a designer is getting confused if there's too much information. You cannot you are reaching very soon the boundaries of your possibilities and capabilities, and whereas, so to say, that this kind of number crushing is that's not an issue for computers, at least not nowadays. So could you say that you're trying to take in the best of both worlds?
Right. So one of the question is like, how much is too much? How can a person is looking at design alternatives, and there is a potential for the system to generate thousands and thousands of variations. But how much can a person who's visually, looking through them, can look at one single time, and how can system interfaces can help that person or designer to ease the process of visualization, looking at the gallery and making sense out of it, making collections, and etc. and etc. I'll talk more on this.
So it's a bit like this feeling you are in a large supermarket, a hypermarket. You're having, so to say, 50, 60 alternatives, and you simply don't know where to start. So it is somehow about guidance, isn't it?
Absolutely, yeah. And the system who's generating it should also support the designers in order to making sense out of it and helping that person to, like the analogy you're using, shop the best one, the best candidate, or at least the best set of candidates, if not the one. Yeah.
Right. Okay. Then what we can see in the next following paper, which is, so to say, focusing on architectural layout. I hope that one of our co-authors is there. Is Hao Zheng here?
Yes, I'm here.
Ah, you are here. Very good. What I took from your presentation and the paper is you are focusing on at an early design stage, right?
Yes, because for this conference, I also submitted some papers for the same topic with generation of architectural plans, but using different methods. For example, machine learning. In this section, it's related to the generative algorithm, so it's more like a comparison of the generative method to the machine learning method. So in generative method, I think we designers should define the rules, but in the machine learning method, we define the data. So there is a difference between those two methods.
Yeah. So you are using machine learning in order to cope with an overload of information to be handled by let's say the human designers, isn't it?
One of my papers talks about the machine learning in section 9 of the generation of architecture plan. In this section, my paper talks about the usage of simulated annealing in doing the same task but with different method. So in this method, we need to define the rules rather than the data, but those are two approaches to the same problem.
Okay. If we would proceed in so to say the papers in this session, then our next author is probably around Su-Xing Gu. He is having two papers, paper 32 and 94, and what I remember from your presentation is that the very last slide is saying research needs to be improved, question mark. Are you saying this, so to say, to provoke the audience and say, well, let me see what could be better, or what is your intention with this statement, Su-Xing?
Sorry. Maybe I haven't got your question point.
Well, you were saying on one of the, I think it was on the last slide, research needs to be improved, question mark. So you are saying I'm open for discussion, or are you saying, well, this work is not so good, but I have to write some paper, so just let's see what is happening. What are you expecting from the audience? Feedback or?
Okay. Most of my work and these two papers, they are all based on the multiple agent system simulation. And from the simulation, we want to get some useful information and use them to improve our design strategy or something like that. So I think my paper in this group maybe more suitable to that simulation group, but it's okay. It's okay. But what I want to get from the audience is that in my research, here is two difficult and two challenges and 2 points. The two most important points need to be improved. The first is that how you define and prepare a good simulation. How to define your simulation is successful for your topic. For example, how you to justify it, and this is the first one. And the second one is how you use the simulation outcome to support the design. Because maybe do I need to explain more here, or?
No, that's perfectly fine. Maybe someone wants to react on this. I mean, overall, what you're saying is that, so to say, the allocation of your paper in a session is as such always a tricky issue for organizers. It also is well, you could probably call it a kind of overload, because there's a large number of papers, 100, 150, there's a certain number of sessions, there are certain uncertainties, and then it can happen that maybe not the best possible match would have been given. Thomas Wortmann is saying, I don't seem to be able to ask questions via the question and answer. Well, you can. If you do so, we will see it here and we can repeat the question. So Thomas, do you want to write it? Or do you want to say it orally?
Yeah, no, I cannot. It's a technical issue. I cannot. I can see the questions, I could answer the questions, but I cannot post questions.
Okay, but now we can hear you, so let's go this way.
No, but so my question is for the next paper, and so the escaping evolution, Ines and Katharina, and I would like to know what are the model-based algorithms that they have used.
Ines? Ines, are you here?
Hello, good morning.
Yeah.
So we used some algorithms that are based on Gaussian processes, and then some that are based on random forests. We use a Python library in the scikit-learn. So we just choose 3 algorithms based on Gaussian processes, and then we choose a meteoristic to go over the approximation to do the studies, and then the Gaussian process to calculate the approximation or the random forest.
Do you want to respond to that, Thomas, or?
No, I think it's clear. I think it would, I cannot find this reference in the paper, but there's a very tiny comment. It would be easier for me if I could actually find these libraries in the paper, but that's okay.
Okay. Well, if you take a look at your title, it's rather provocative.
Yes.
Escaping evolution. Can we escape evolution if we would wish to do so, even if we do our best, Ines?
So what I conclude with the paper, it's what other authors have also concluded. It's that for every optimization problem, there is not a single algorithm that constantly outperforms all others. So for some problems, we can escape evolution. In fact, I used 2 case studies in the paper, and for one of them, we could clearly escape evolution. That is the evolutionary algorithms. I tested the NSJ2 and the SPA2, but for the other, we could not, and we can clearly see that NSJ2 clearly performed better.
Okay, thank you. Someone is writing, we can not even escape the virus. Okay, you're right. In the next following paper, which is about heritage management and avoiding queues and so on, have you considered, Nanbai, to say, well, if this is all such an issue to handle the streams of people, why don't we go 100% virtual?
Yeah, as we have been in this pandemic for like more than half a year, we are so, how to say, we miss the real environment so much, and we can have the chance to view all the museum objects and all the museum environments virtually, but still we need that feeling of being in the presence. So that kind of in situ feeling, and you need that kind of, for example, in our paper, we are dealing with the Palace Museum in Beijing, and it's very important to be in the same place where the emperor lived and worked, so everyone can feel that essence. So it is something very important. So we need to rather manage the tourists to protect both the tourist experience and also the heritage, but we and rather than to just give it totally to the virtual environment.
I fully agree with you. For example, some of you might be familiar with let's say, these characteristic images from Machu Picchu in Peru, and you see the Huayna Picchu, the little mountain in the back, but it's very hard to grasp the real dimensions and size. Now, I've been there a couple of years ago on the occasion of one of the CAADRIA conferences, and it was incredible to see how large it is and how easily you can spend a day. So indeed, the real life experience is very hard to replace, and probably also your research could be of use to to other museum and heritage sites to let's say control the access.
Yeah, right. For sure.
Yeah. In our next paper, which is focusing on architectural floor plans and especially the adjacency requirements, I was wondering, this has a relatively strong layout, a two-dimensional focus. Have you been considering what would happen if you transform this into the third dimension, so to say, because not always buildings are consisting of just one floor, there are connections, or is this simply too complex? Krishnendra.
Yes, so I think if we think of the multiple floor buildings, then we have to consider adjacency in two forms. So it's horizontal also and vertical also. So right now we are dealing with, because we are trying to generate the floor plans with the rectangular boundaries only, where the user can give the adjacency relations and they can also give the boundaries. But we are working on many other things. For example, user can choose for each room the orientation also. They want it to be on the north or to be south or like this. Trying to include the circulations also. I think once this part is complete and once we get the architectural inputs, then multiple can be thought about, because then we have to just consider, so we can build a floor plan separately for each floor, and then we have to consider the vertical adjacency. We haven't started working over it, but that's one more form of the adjacency that need to be considered.
But overall, so to say, topology is a very strong focus area in your work, isn't it? The relation between spaces, not necessarily solely the geometric form.
Yes.
Okay. Please, to the audience, feel free to pose any questions. I will do my best to watch the chat and to keep the discussion going. Let's continue our first round through the papers. The next paper is the paper I'm the co-author. We were simply considering that CAADRIA is now celebrating the 25th anniversary, so there is a large number of papers, and what we've been doing basically is watching what are the topical areas announced by the organizers, what is depicted in the proceedings, and it turned out that singular terms are not very interesting. Far more interesting are so-called n-grams, and maybe a very famous n-gram is building information modeling. It's a trigram, three terms together, whereas, so to say, building or informational modeling is a standalone term, far too wide. But if you put this together, actually the so-called bigrams, like digital heritage or generative systems, it's worthwhile to see how this is moving on. Now, before I'm having too much self-advertising, we have been speaking already with our colleague Shunsiksa Yang. You do have a second paper which is focusing on Shanghai now, where we were shortly speaking about the Beijing paper with the hidden city. Do you see here some inspiration to follow your to move on with your work, because you are interested in patterns of movement, right? That is a question to Xunxia Yang, but either I'm not any longer online, but that's not the case. Probably he went for.
Sorry, Bob.
Yeah.
Is that question for Ms. Yang, Chunxia Yang?
Yeah, right. Right. That's you, isn't it? Mm. Okay.
Yeah.
Do you see a relationship to the heritage paper on the hidden city and so to say the movements of the peoples? Whereas in your Shanghai paper, you're also studying the movements, isn't it?
Yeah, in that paper, we test to simulate some behavior and based on the texture of an old traditional texture of the Shanghai old town, and try to generate a new structure for the public space system here, and to get the old town to a regeneration, so that is a test, but many places we need to improve it.
Okay,
and that isn't just support give some information from our outcome from our particle distribution. That is the information we can utilize to do the new design. But the system of the particle is not the design itself. It can support the future design. I mean, yeah. Thank you very much.
Okay, you're welcome. In our next paper, which is focusing on fantastic facades, you are in high competition with the paper from Ines Pereira regarding the title. She's speaking about escaping evolution, but you are speaking on about fantastic facades. It's work with fourth years students on facade design. I was wondering, would you see some scaling issues when you're working with smaller mock-ups and in relation to so to say 1,000 square feet of facade surface? How valid is it to work with a mock-up, or would you see this as a playful mean?
Yes, thank you for the question. And well, first I have to say that there's a limitation on what can be done, because this is an undergrad program and students are not familiar with the research approach in design. And this was more like an experiment in studio. So everybody thinks of facades as just a surface. And I thought that it would be good to invoke ideas about what is actually behind the construction of facades and making it practical. So the process is more the focus of this research, so that students would start with making geometries and finding interesting ways to come up with diverse geometries, bring it from nature, doing parametrics, and therefore slowly look into the practicality of the surface support system that would relate to what you're asking, and apply some interactive techniques or performative qualities to the facade, so it has some kind of meaning. And the meaning could be performative, it could be representative, it could just be the look and feel or the color or texture, and the kinetic qualities of it. But the last is the most important, is how it relates to the context. And this hits directly to what you're asking about scale. Because if you were to provide a facade and extend the use of a building beyond its initial use, and we will see this as a trend coming up in large cities like in Bangkok, where you can't afford to demolish a building and build something totally new. You'd have to revamp or revitalize and use a new facade for that. And so students were looking into how it could fit in the existing structures, and each and every panel that is parametrically designed would have to accommodate those slight changes in the context. So it is something that you cannot do manually, or if you can, it would be extremely difficult. They would be working with Grasshopper and making piece by piece with some kind of interactive technique to it.
Yeah, right. Now, it's often said that the building industry is very conservative. There's a handful of facade systems, and if a project is coming in, you are sort of very arranged in one of these streams, and it will not be invented from scratch. That is rather pessimistic. Have you been considering to get in touch with representatives of the facade building industry and to see how they react and what, so to say, their views are, or is that too early?
Well, we did have a panel reviewer who actually worked on the Apple Store in Bangkok, and it has recently been revealed. So it's really about how to hide a lot of the structures and making this very serene and clean facade. He gave quite a lot of interesting
insights.
Yeah, insights about in practice about facade designs and firms who design facades only. That it's really about the support system, and they have to find a way to best hide or make sure that it's seamless. It's not apparent to anyone. And if you can manage to do that, then you would succeed as a facade designer, which to me means that we're trying to avoid showing the practicality of things. But that's another approach. I think it's important for students to see in both sides.
Right. So we can expect more work here.
Yes.
Well, in the meanwhile, I would also ask the audience. We are quite a few people, around 60, which is not so to say. It's well attended overall. We do have another 10 minutes, but first think about your questions. We can take a few, but there's one more paper from Thomas Wortmann and Tom Fischer with also a very interesting so to say consideration somewhere in the presentation, saying whether architectural design optimization requires multi-objective analysis at all. In other words, even if we can do things, does it make sense to use all these methods? What would you say to that, Thomas?
Right, thanks. I think you summarized it very well. And of course, so in the paper, we discuss a lot of arguments why it might be necessary to use multiple objectives, also some motivations why people use multiple objectives. And then we also say, well, but maybe this doesn't always apply. So I would say, of course, the answer is it depends. But I would, building on what you said, yeah, just because indeed we have a multi-objective algorithm doesn't mean you have to use it. And going further, even just because you have multiple objectives you want to optimize and you have a multi-objective algorithm, that still doesn't necessarily mean that you should use it now, because that's one of the things we discuss is multi-objective optimization is very difficult. So one should always try to somehow reduce the objectives if one can. And the paper gives some examples, some ideas how to do that, and also some of the reasoning why you would want to do it, why you might not want to do it. And also, I was building on what Ines showed. One of the things we also mentioned is that there's a lot more testing is needed, because in fact, very little is known about the reliability of the these algorithms, which we can already see in Ines' paper. There's 2 case studies with, it seems to me, very different results. But then we should not despair, I think. So it's not true that, because if you really believe the free lunch theorem, that means it would be random. Basically, that every time you have a new problem, the performance will be completely random. And of course, that is not true, because the freelance theorem assumes that all the problems are randomly distributed. But I would say they're not. No, there are a lot of, like, if a lot of structural optimization problems are kind of the same, and a lot of energy problems are the same. And so we can expect to find certain regularities in the performance of these algorithms. But in order to do that, we need, of course, to have a lot more case studies.
And where do you go from here, Thomas? I guess your work in this area will not be terminated, right?
Right. So thanks. That's very good. So yeah, what I'm saying is definitely one of the things. So more testing, and I mean, I think really big. Probably we somehow need to have some kind of database to gather a lot of problems and a lot of results to try to make more generalizable statements. But also developing other algorithms. So EKD next month, I will show some testing of an algorithm that I have developed. And also the other thing is what we also still need to do is also has related to what Shireen has talked about. After you've done your optimization, I think we can still do better in visualizing the results.
Okay, so more to come. In the meanwhile, I've seen that there was one question from Yurion Park to Likai, asking what is the uniqueness of your approach compared to other evolutionary approaches, whether you could explain this very briefly. Likai.
Right. Yes, yeah. Thanks, Paul. Thanks, Yongjun. And I think the main difference is that where to start your evolutionary design optimization. In the previously or the conventional way is that one premises is that many papers says that the result of the optimization is the starting point of the design, but usually you have to develop or conceive a design concept first. For example, you want to have a building with a central courtyard, and then you use this parametric model to do the optimization, and then you get the result. The result is still have one courtyard, but you cannot get the information about whether the courtyard is the right strategy or how many courtyard is the right number. So the difference to the previous approach of my system is that you can run the optimization before your design ideation, so you can get the information first. For example, in the case study I show in my paper, there are some the results show you that you can use like a self shading to have a better solar irradiation utility. So this is information you can use in your design process, and then you don't need to use the cell shading. You can just using the external shading to replace that. But this information is more critical. So so instead of just give you a solution, my approach is more about to give you the information of how you to really improve the building performance before you do the design. So this is my answer. Thank you.
Mm-hmm. Okay, we still have a few more minutes, maybe for one or two questions. Let me see. There's nothing in the chat at this time. Maybe one of the panelists wants to put on a question. Then let me ask Nanbai, what is your, so to say, the next step in your search? Is it already under implementation or very soon to come?
Yes, our research was like to calculate the Turing program of the list, and it has been approved and presented to the directors, and it is being used as guidance for the exhibition planning. So, but unfortunately, they are not going to be opened this year, which was planned. So perhaps next year you will all see how this kind of tourism management is going to work in Palace Museum.
Okay, so probably then the proof of the pudding is the eating. Then we will see how it is working, how refinements and adjustments will take place. I think real time was also an issue quite a few other panelists were referring to. For example, Ines Pereira, she was also speaking about the wish for real-time representation, correct, Ines?
Yes, correct. I do believe that for us to quickly understand how the optimization is progressing, it is important that we have real-time visualization mechanisms. For instance, a parent front that is being computed as the algorithm analyzes new solutions, as well as the fact that we can click on those solutions to see what results are being produced. In this way, we can understand if the optimization can be stopped sooner, because we already have a result that we like and that we are satisfied with, or if you want the optimization to proceed, for instance.
Okay, thank you. Well, I'm in this regard very confident that this is not the final session on generative, algorithmic, and evolutionary design. There's more work to come in the next 25 years of CAADRIA existence. What we have been seeing is that time is really moving very, very fast. So apologies if there would have been a wish for further exchange. However, I think people have been, what I can see from the chat, already been speaking and talking to, well, writing to each other. So that's also one of the main aspects of conferencing. With that, I would like to thank you for your attendance, the panelists for their presentations and their availability. We are moving now to simulation and analysis session 3, which is chaired by Kuyung Hoon Hyun. And he is going to take over. So all the best, and we will be meeting somewhere in the virtual or eventually in the real space. All the best. Thank you.
Thank you, Bob.
Hello, everyone. I guess everyone is here. Because I checked, Shuai Lu was here, Chael and George and Ji Huai, Chi Chao, Ines, Limin Sang, and Michael Yao. I guess everyone else. I guess we do have everyone. Okay. Okay, so we are going to start. Hello, everyone. My name is Kyung-Hoon Yeon. I also go by Hoon, and I'm from Hanyang University, Seoul, Korea. And welcome to the session 3, simulation and analysis. And everyone will have approximately 3 minutes for the discussion, followed up by a quick, brief speech of your paper. And for the panelists, the ones who's presenting or answering questions for the session, please turn on your camera. And if you have any question to other panelists, just use microphone to ask questions directly. Because I've noticed there are some lags if you use a Q&A. And for the audiences, they don't have access to microphones, so you have to just use the Q&A feature to ask questions. And I will try to bring it up as many as possible. Okay, first, Chun Chao, could you please briefly tell us about your paper?
Thank you, Hun. My paper the idea is pretty straightforward, actually. I've seen a lot of optimistic efforts today and always, but I'm more of a pessimistic, maybe. I always want to check if our ideas are reliable under different circumstances. So this paper is about building form optimization based on building environmental performance, but with the uncertainty of boundary conditions, including material properties like occupant behaviors, etc. So we investigated the optimal form under different circumstances, and found that the uncertainty lies in material properties and other parameters can significantly change the optimization result. So this shows that when we're conducting building form optimization, we really need to control the uncertainty of other parameters. And it is also found that the most influential factor is the visual transmittance of glazing. And on the contrary, occupant behavior is less influential. So that's basically the content of the paper. Thank you.
Thank you. Do you have any questions from the panelists? Okay, I have a question. I enjoyed reading your paper, and I had a question about how challenging was it for you to model the occupant duration and occupant schedules, because you had like 5 different variations, and
yes,
that is, I think that's quite important for your research results. So
yes,
like how difficult was it, and how did you model the OCD and OCS?
Yeah, yeah, that's quite challenging. Mostly we get it from the design standard and criteria. For example, for the occupant density, so the design standard is shows that you can have a minimum area of 4 square meters per person. So if you go below than that, that's not feasible due to the design requirement. And also, we go through several research papers and show that basically the occupant density will not be larger than 25 square meters per person. So then we can see that it is possible for a building to have an occupant density from 4 square meter to 25 square meter. And or between this area, there lies the uncertainty. So then this is how the occupant density is set. And for occupant schedule, is quite the same. We have a standard scenario from the standard, and also we read several papers to get other possible scenarios, and then we investigate whether these settings between these possible scenarios can significantly influence the optimization results.
Thank you. Any questions to Shuai? Okay, thank you. Then we're going to move on.
Thank you, Hun.
Yep. And the second presenters, Chael on insulating geometry. Hi, if you could tell us briefly about your paper first.
Yeah, so our main question was what happens if we change the geometry, manipulate the geometry of a concrete tile for a building facade? And we wanted to see if we can improve the insulation of the tile by changing the geometry. And so what we did, we examined a series of tiles, also in a wind tunnel, like a physical wind tunnel in experiments. And in the same time with digital simulations, we made a validation to see that we're getting the same results. And the interesting thing that we've got, and the main contribution is that we saw that there is a potential with improving the thermal performance of these kind of tiles. One of the interesting series that we have is a series that is mimicking the fur of animals. And we saw that specifically in this series and in other geometries as well, probably they're trapping air inside, and they're enlarging the boundary level on the facade. So this is the main interesting thing that we figure out.
Okay, thank you. Any questions from the panelists? We have about like 80 attendees. We don't have any questions. Okay, I have a question. I guess, yeah. So based on your figure 5, first of all, I really enjoyed your paper. Based on your figure 5, it seems like the heat transfer barely varies within the same surface types, except for the basic bumps. So so it was quite difficult for me to interpret this. Could you just tell us exactly how we could use this research finding to the... Yeah.
What is barely changing?
So for example, the flat tile, the heat transfer rate doesn't really change except for the exposed surface ratio on the figure 5.
Yeah, so you're probably talking about the heat transfer rate is pretty close in the geometries, but it is a big difference. For example, it moves between 2 to 5, so it is a big difference. But what we see in this figure is that that is very interesting is that as we enlarge the exposed surface area, we get better results. We get lower heat transfer rate, which is not an expected result because usually radiators, for example, in every geometry that has more surface area, larger surface area, we use to the fact that it's not improving, but it makes the heat transfer rate higher. For example, when we use larger windows in a building or a larger roof, so we have more heat transfer rate, right? So this is the surprising thing, and the reason is that the possible reason is that it traps the air inside and enlarge the boundary layer. So this is what we can see here, that as the exposed surface area is larger, then the heat transfer rate is lower. And you say that it's not a big difference, but in these numbers, it is a large difference between the geometries.
Okay. Okay, so thank you. If you have any questions, just please use the Q&A feature. And the next presenter will be Jia Ding Zong.
Hi, I'm here. Hi.
Hello. So if you could briefly tell us about your paper.
Our study is based on a fundamental belief that if we can create a thermally comfortable outdoors environment, we can encourage the urban residents to go outdoors to exercise and reduce the use of air conditioning, so we can build healthy and sustainable cities. We look into this issue, basically how to create a thermally comfortable environment, and we find a commonwealth in the academia that we should use vegetation to cool down the thermal environment. So we built up a safety model to modeling the vegetation's cooling effect, and we aimed to study how the densely built up urban morphology of Hong Kong affect the cooling effect of vegetation. Okay. So that's what our study is about. Any question is welcome.
Okay, I have a question.
Yeah.
So so have you considered connecting the prototype to like a knowledge-based system with the tree information? Because based on the equations that you wrote in your paper, it seems like the LED values are. It's really important to have the density and the height of the trees.
Yes. Hopefully, we strictly speaking, we should do some in-depth literature review or some field measurement to to get accurate values for the LED. But in this study, we are trying to build up a say explorative model. So we borrowed the value from the published study, which may not be accurate in the real world. So maybe in the future we will try to figure out a way to accurately determine the value for LAD.
Oh, okay.
Thank you.
Thank you. Okay, so we're going to the next paper, an investigation of a deviation of microclimate simulation by Guo Ji and Hainan Yan. Do we have the presenter? Guo Ji and Hainan Yan.
Can you skip this one? He's my colleague. I am trying to contact him. But
Okay, so then we can come back later.
Yeah.
Okay.
Thanks.
So Qi Guo, the research on spatial distribution performance.
Hello?
Hello.
Yeah, I'm
Yep.
I'm Qi Guo. You mean Qi Guo and Hong Yuan Mei? Is that a paper about sports facilities?
Yep. So if you could just briefly tell us your paper.
Okay. The paper takes the Harbin city in Harbin as in China as an example, and we croned the website and we use the ArcGIS to get the accurate geography information of mass sports facilities. And then we evaluate the quantity distribution and type distribution of the mass sports facilities. The paper is aimed to evaluate the health service performance of the existing mass sports facilities. And we provide a reference for the design and planning. The innovation point of the research is about the method. And the first is a method to get accurate statistics of the existing mass sports facilities. And the second is a method of web crawler for specific POIs without accurate search names. And we break through the original restriction of the research on the spatial distribution caused by the lack of urban management data, and we avoid the sample interference caused by the artificial sampling. And that's all.
Thank you. Any questions to Qi Guo? Okay. It was quite interesting because you use the social network data. And could you elaborate on the data set? What more data was available and what was challenging for you? Because, for example, if it's social network data, you could conduct sentiment analysis or any other NPL analysis too. So could you elaborate on how, like what kind of social network data you use and how, and if you have any future plan, how would you use that data?
Okay, and now we get our data from the Gauda map and a social network called Elevation Network. I think that's the translation. And now for just now, we can just get the latitude and longitude of each sports facilities, and we also can get the function of each facilities, but we still cannot get the area of each one. So we just can do the accessibility analysis and the distribution analysis, but we still cannot analyze how large of each facilities and how and the capacity of each facilities. And the challenge we met is main about the names and the search names. As we know that the POIs, we need a accurate search name because, for example, hospitals or hotels. All of the hospitals is hospitals, named hospitals. But sports facilities, some of them is gyms, some of them is stadium, some of them is sports center, and some of them is, yeah. So for that reason, you search them on the map, you get a lot of disturbed and interference data. And we need a lot of work to cleaning the data. So we use the method we get in this paper. We combined the evaluation website, the social website, and then they give us a series of data of mass sports facilities, and that make it more clearly than just searching the names.
Okay, thank you.
Thank you.
Okay, so next paper by George Stojanovic. Did I say your name correctly? He was here. How to share a home. Hello. Okay, hello. Did you turn on your microphone? I can't hear you. I guess it's typing. Okay, so yep, so we're gonna wait like 30 seconds. Okay. Oh, I can't hear him. Okay, so while he's figuring out his microphone, like we can always come back. So let's move on.
Just one last try. Can you hear me now?
Oh yeah, I can hear you now. Great.
Yeah, sorry about that.
Yes.
Something funny is going on with my computer. Sorry about that. Apologies again. Yeah. So
no
our
problem.
paper is about housing, and our research specifically relates to communal areas of housing. So what we've tried to do is to devise a tool and come up with a blueprint of a proposal for further research, which will help us understand what goes on in communal housing areas. So we know that private housing parts, our homes, are subject to strict codes and guidelines, while in communal zones, we know that there is more freedom and less typological certainty. So what we try to do is to use a network of sensors distributed in communal housing spaces to harvest information to help us with the list of computational techniques, help us understand how is this space used, who's using it, and at what times. So we've drafted a framework, and this is what we presented in our paper.
Thank you. Any questions from the panelists? Okay, so I really enjoyed reading your paper.
Thank you.
And especially you're analyzing behavioral patterns through a set of sensors. And I think it's a very important and timely topic in the field of computational design and post-occupational evaluation. But then in computational design, a lot of designers claim that if you simulate the behavior patterns after the design was conducted, then it's too late. or there's no way you can simulate the behaviors unless you have the building. So there's like this, what should we call it, like a very thin ice thing. So I would like to get insights from you on how your model can help the design process or the design revision after the building is designed or before the building is designed. Like, how would you?
Yeah, it's often mentioned that designers do not know what happens after the design decisions are being made and once the buildings are being occupied. So we believe that this tool will have a benefit to let designers know what happens in real time. So that knowledge can be used for predictive analysis. So if we keep on feeding the model with the information as we were suggesting, we hope that we'll be able to acquire predictive capacity. So we could tell in future where people will be and how they like to use that space. For instance, we will know if certain areas of the communal space are used more so than other areas, or we will know that certain residents do tend to use certain communal facilities more than other ones. So that information can be valuable to designers. But also, we believe that this tool can be valuable to occupants themselves, so they can plan their time and the use of the space in a more efficient way. So it's kind of between occupant and the architect where we see the benefits, but it's in a long term and it's about acquiring information in short.
Thank you.
Thanks.
Okay, so we're moving on to the next paper by Erhan, Halil or Erhan. What do design data say about your model?
Yeah. Our research is based on a very simple principle, which is measure twice, cut once. In today's world, when we are designing buildings, they are very, very complex. And the models that generate them are very complex as well. And the problem is, how do you measure these models? How do you measure these models? Verify that they are doing what they are supposed to do, and validate that the outcome is acceptable. So the problem in working with today's computational tools, including parametric modeling and mainly parametric modeling, is that you deal with so many different type of modules and components. Some of them are written by other people, some of them are written by you, some of them inherited from the geometric modelers' underlying structure. And it's a very complex model that you are dealing with. There is no way you can measure its capacity, where it can fail, where it can be successful. So we said, how do we reveal the model features to the designer without interrupting design process? And we looked at other disciplines, and we found that visual analytics seems like is the fastest way that you can reveal anomalies in a design. So we adapted visual analytics system to analyze a given model to identify where the reliability and validity issues can be, and we responded that, and we presented it in a case study in the paper.
Very nice, thank you. And so if I read your paper and presentation correctly, so you guys conducted a post-experiment evaluation with the, yeah, so let's say the users, the participants were creating models, and then the system calculates, and then there was the design analytics part, and then the design.
No, this is a methodology paper.
Yep. Mm-hmm.
It is not an experiment evaluation paper. We are proposing a methodology that looks at how we can analyze a given complex model, parametric model in this case, that is built by multiple people. There are multiple design solutions and dealing with complex performance issues. And that happens in real world. And the case study that we are using to demonstrate the methodology is coming from a smart geometry group that worked on creating a high-rise building in a downtown, North American downtown metropolitan city with complex functions in a setting. So the methodology presents how visualizations can reveal reliability and visualization
reliability and validity issues in a complex model, similar to the case study we presented. And we call the methodology design analytics.
Okay. Do we have any questions to Halil?
Thank you.
Okay. Thank you. Okay, next is Hoyoung Meng, optimizing tensile membrane structure architecture. Could you give us like make a quick brief of your paper?
Hello, can you hear me?
Yes, we can hear you.
A tensile membrane architecture was defined as a new mean for collecting energy from vibration in our research, and this paper identifies the correlation between the material stiffness of a tensile membrane and wind-induced vibration in a tensile membrane architecture. Then optimization of the tensile membrane architecture and a harvester for the collection of energy from wind-induced vibration was proposed. In the energy harvestable tensile membrane architecture, less vibration is desired to ensure the stability of the tensile membrane architecture, while high vibration promises a good energy efficiency. Thus, two multi-objectives to optimize the tensile membrane architecture were the stability and the amount of energy harvested, while the shape and the stiffness of material were the controlling parameters. We discovered that the stiffness is negatively correlated with the energy collection, and also defined optimized design solutions of tensile membrane architecture, which have been visualized in the paper. And this paper proposes a new type of architecture that integrates energy harvesting with the tensile membrane architecture, and developed a method. And we developed a method to optimize the tensile membrane architecture for energy harvesting to assist designers when they make decisions about their design, including its form and the material used. So to the best of our knowledge, this paper is the first attempt to identify a correlation between wind-induced vibration-based energy harvesting and membrane stiffness levels. That's it. Thank you.
Thank you. Any question to Hoyoung from the panelists? Okay. So your paper, you're optimizing the various tensile structures for energy harvesting with fixed placements and fixed variables. Then how would you implement your research on the real world scenario where the wind condition and direction changes consistently? Like, would you make it in like interactive or like?
Pardon?
No, the question is, currently you're experimenting, you're optimizing 3 structures with fixed placement.
Yes.
With the fixed wind conditions, but yep. In real world setting, the wind condition changes.
Yeah.
So how would you so what's your future work? What's your plan for?
My future work is to variate the wind condition according to the real environment of cities. And in this paper, the anchors of tensile membrane architectures are fixed. So I try to rotate the fixed anchors according to the wind condition and make better optimized tensile membrane architecture, and that's my future works.
Okay. Thank you.
Thank you.
So next paper, Ji-Huai Cheng. On parametric modeling and simulation of an indoor temperature.
Yeah, hello, can you hear me?
Yep. If you could briefly tell us about your paper.
Okay. To address the challenge of overheating in office buildings during summertime, we proposed a parametric modeling and strategy for developing dynamic intelligent solar shading system. Informed by the Arduino-based physical computing prototype modeling, we formulated a temperature angle mapping concept and 6 specific methods for shading system design and simulation. According to the simulated results, the indoor temperature responsive rotational shading system can produce more total comfort hours, reduce cooling energy demands, and decrease indoor temperature during the summer months. And we also get that the optimal one is horizontal shading with linear mapping in our 6 methods. Yeah, thank you.
Okay. Any questions or comments? Okay, so Mike, I have a question regarding the physical model and the simulated models. Could you just elaborate on the relationship between the physical model that you made with Arduino and the simulation that was conducted through the Grasshopper?
Okay. Our physical model is based on the Arduino platform, so that we can use some electric elements, for example, servo motor and temperature sensor to sensing the real-time indoor temperature and drive the shading blinds. And we use a component in Grasshopper to connect the Arduino Arduino physical computing model with the virtual Grasshopper simulated model. Yeah, so in our virtual parametric model, we simulated the total cooling energy, cooling energy demands and total comfort hours and indoor temperature to check that the building performance of our shading system design. Thank you.
Thank you. Okay, so we're gonna move on to Ji Chao Ma, research commercial space for vitality of airport terminal.
Can you hear me?
Yes.
Okay. What people say when walking in commercial area of the airport terminal has a direct impact on their shopping behavior, or the commercial space vitality and the commercial planning and the position of the advertisement. We use MathMotion software to simulate the passengers' dynamic 3-dimensional vision field in the airport terminal. The MathMotion 3D vision field simulation of a pedestrian flow has certain application prospects in airport commercial space organization. And by using MathMotion, we proposed a dynamic 3D view simulation method based on pedestrian motion. This simulation method makes it possible for designers to analyze and test the 3D building space layout, which provides strong support for seeking the option building space layout. This research can also be combined with the POE to evaluate and verify the space layout of the building environment, signal system evacuation efficiency, and so on. Thank you very much.
Thank you. Any questions to Jihao? So you used the MathMotion.
Yes.
And can you? I've never used MathMotion, but can you use it in a outer environment as well?
Yes. It can be used in indoor rooms or in the street, or it mostly uses to simulate the pedestrian movement, so it can be used in many situations.
Okay, and also for the buildings with multiple floors.
Pardon?
So buildings with multiple floors.
Yes. It's a three-dimensional software. Pedestrian movement can move from one floor to another floor.
Okay, because usually in space syntax, because of the height information, it's really difficult to simulate the one with the on 3D, and so it was very interesting paper. And if we have any questions from the audience. Okay, so 5 more minutes. Okay, so we're gonna move on to Ines Catania. Thank you, Chichao.
Hi, can you hear me?
Yes.
Can I share my screen? So it's just to show a slide.
Sure.
Okay. So the aim of our research is to help the architect in the development of algorithmic design solutions. And in this paper, we proposed a workflow that facilitates the design exploration of solutions developed with algorithms, while automating the analysis regarding different criteria at early design stages. At early design stages because it is where the design changes are easier, faster, and also cheaper. We evaluated the workflow by focusing on structural analysis, but the workflow is intended for any kind of performance analysis that can be automated. So we believe that using the workflow reduces the number of interactions between the architect and the engineer, as it allows the architect to filter the viable ideas and optimize them regarding different criteria before talking to the engineer. And this will save time and effort. The optimization is not intended to find the best possible solution, but instead to present a set of solutions with the best trade-offs for the architect to choose. So in the paper, we demonstrated how different design options affected the structural performance of the design solution being developed, allowing the architect to be more aware of the impact of his ideas and his changes to the design. Thank you.
Thank you. Questions to Ines?
I have one.
Okay.
On the slide that you shared, also in the presentation that you had in this, you had arrows that goes from some data visualization to optimization. What does that mean? I can understand or interpret at least the other arrows, but that I couldn't understand.
So the arrows. So this means this is the algorithmic.
For the sake of saving time, it is this one particularly.
Sorry?
But if you look at the screen, it is the one that, yeah, the red one. Yeah, you see the red line I'm drawing?
No.
Okay, so there is a graphic image on the lower right side.
Yes, now it
and
is.
then it goes to optimal solution. What does it mean?
So this represents the optimization process. So this arrow means that the best solutions are filtered. So the architect is presented with the best options, and then from these options he can select the one that most pleases him, that makes the best balance with the requirements that are needed and his design intent.
Okay, yeah, it makes sense. I didn't understand this in the presentation.
This is the optimization, this is the analysis.
Okay.
Okay, thank you. So the next presenter, Li-Min Tseng, on representation of sound in 3D.
Hello.
Hello.
My study is about representation of sound in 3D. This study is for how to capture and reconstruct invariable sound data to create three-dimensional forms. A series of steps are taken to record the canonical figure of different frequency and decibels. The slices of sound image during the vibration process are taken out on the type S and converted into first point count representation and becomes 2.5D slice layer stacking and finally 3D form transformation. And through the proposed methods of processing and representation, sound not only stay at the level of hearing, but also can be seen and touched. Thank you.
Thank you. Any questions to Limin Tseng? Okay. I have a question to Limin Tseng. Thank you for your presentation. And so could you please elaborate on like the next step, the future work on the current research, since it seems more like the proof of concept. Like what are you gonna use your the current paper into some other research?
I think our next step is to keep the connection, the sound shape to the space design, because I think the artist or designer can use this process to make some design on the shape.
Okay. Thank you.
Thank you.
Okay, so the next person would be Michael Yell on immersive simulation. Hello.
Can you hear me?
Yep.
Hi. So my paper is titled Immersive Simulations of Acoustics for Building Analysis. So the objective of the paper was to investigate the use of Unreal Engine as an alternative means for simulating acoustics in a virtual environment. So it kind of provides qualitative information that is not present in most of the conventional acoustic simulation tools that are available to a student like myself. So the paper also investigates how the program can also be a part of a simple yet rigorous workflow with Rhino as well as Grasshopper to produce designs that respond to like the visual and oral demands of a given project. Yeah, and so over the course of the study, I was also involved in like figuring out and doing investigative studies on how like Unreal Engine can be quite compatible with like some of the conventional software that architects use nowadays to create some of the designs that you see in the paper as well as presented in the videos. Yep.
Any questions to Michael? Okay. So it was really interesting paper because there's a common debate in design field where the form follows function or function follows form, but your paper talks about form follows acoustics. And could you tell us like what other softwares are there to aid acoustics during the designing the building compared to your Unreal Engine implementation?
So I did like test out native acoustic software. I mean native acoustics software that are like conventional with Grasshopper, like Pachyderm, or like other softwares that are maybe not compatible, such as like iSimpa and other things. But I think in terms of, I was also looking at how accurate it was and how immersive it was, because as a designer, I didn't really understand how the numbers kind of translated into how like it would really sound like in real life. So I selected like Unreal Engine as an alternative. That's how it kind of inspired this paper. Some of the software that I also tested was, I mean, of course, as I said before, like it gives me quantitative data, meaning that numbers are outputted. You can kind of see like heat maps of like the areas affected and how like the different frequency levels would affect the decibel levels at certain areas. But to me, it was a bit hard to understand, and so I kind of like went in a different direction and chose like maybe Unreal Engine as an alternative means to do so, so that I could better understand how like my different designs can kind of affect the kind of like acoustics of the space, and then vice versa, and how the acoustics helps me to inform what kind of design I should have. Yeah.
Okay. Thank you. So, yep, the time's up, and thank you guys for participating. Hopefully we can all meet in the physical conference starting from next year. And there are a lot of questions from the Q&A feature as well as the chat. So if you guys didn't have chance to ask questions or answer the question, you can always email to the presenter. Okay. Thank you.
Thank you.